Good morning. Welcome to algebra class. From this week lesson, logarithmic functions as inverses, from textbook pages 451 to 458. Before we start, I want you to prepare the following: your algebra textbook, your pen, and your copybook. Before we start, I want you to watch this video.
Let's learn about logarithms. To help us understand logarithms, let's go ahead and take a look at something we should already be familiar with: operations that are opposites of one another, or inverses of each other. So let's say we're dealing with addition in an equation, but we want to get rid of that addition. We want to undo it. Well, to do that, we perform the opposite operation. The opposite of addition is subtraction. So these are inverses of one another. They undo each other. So if we take a look at an example, let's say we have y equals x plus 2. Here we're adding in this equation. Now, what if we want to take this equation and solve it for x? So get x by itself on one side. Well, to do that, we need to get rid of this adding 2 on that side. So we subtract, perform the opposite operation. Subtracting 2 from both sides, we get that x is equal to y minus 2. These equations are saying the exact same thing, since addition and subtraction are inverses of one another. Now, what about multiplication? If we're multiplying in a problem and we want to undo that, we want to perform division. Multiplication and division are opposite operations. They're inverses. They undo one another. So, say we have this, y equals 2 times x, where we're multiplying. And we want to take this equation and solve it for x. Well, to do that, we divide both sides by 2, and we get x equals y over 2. These equations are saying the exact same thing. Now, what if we're dealing with exponents? Exponents are where we have something raised to a power. Well, to get rid of that, we can take the root of it. So say we have y equals x squared. We have something raised to a power. And we want to take this and solve it for x. Well, to do that and remove that square, we need to take the square root of both sides. When we do, we get x is equal to the square root of y. Cool. Okay, now what if we have exponentials? An exponential is where we have a variable in the exponent. What operation undoes that? What is the inverse of an exponential? Well, let's take a look at a problem. Say we have y equals 2 to the x power. So there's a variable in the power. How do we take that variable x, remove it from the power, and just get it on one side of the equal sign? How do we solve that? Well, to help us figure that out, let's take a closer look at that problem and see what we can come up with. So let's say that we have 2 to the x power equals y. Except let's say that y equals 16. That way we can just focus on solving for x. So what we're asking is, how many times do we need to multiply 2 together in order to get 16? Well, let's see. If we take 2 to the first power, that's just 2. If we take 2 squared, that's 2 times 2, which is 4. Taking 2 to the third power is multiplying 2 together 3 times. That gives us 8. And if we take 2 to the fourth power and multiply 2 together 4 times, we get 16. Hey, we found our answer. 2 to the fourth power is equal to 16. So we would need to multiply 2 together 4 times. That means that x is equal to 4. So we solved this. But is there a better way to write this, where it's a little bit easier to manage? Well, yes, there is. We use something called logarithms. So let's say that we have this problem again. 2 to the x power equals 16. This is an exponential form. We can actually take this equation and rewrite it in what's called logarithmic form, using logarithms. This equation, rewritten as a logarithm, is this: log base 2 of 16 equals x. Here we can see we have the word log. Then down and to the right of that is the number 2. 2 is the base of the log. It's also the base of our equation when we're in exponential form. Then 16 is what we're taking the log of. This reads log base 2 of 16. 16 is what our exponential is equal to. Now our log is equal to x. X is the exponent in our exponential. So we can actually take a problem like this and rewrite it as a logarithm. Then we can solve it. Here, this would be equal to 4. So if we want to undo an exponential, we can use a logarithm. So those are inverses of each other. If we have this, y equals 2 to the x, then we could rewrite it as x equals log base 2 of y. These equations mean the same thing, since exponentials and logarithms undo one another. So now let's take a look at the definition of a logarithm. A logarithm to a positive base b of a positive number y says this: if y is equal to b to the x power, then x is equal to log base b of y, as long as b is not equal to 1. So we can take a problem like this and rewrite it using a logarithm. So let's say that we have 3 to the 4th power equals 81. Well, we can actually take this and rewrite it with a logarithm. All we need to do is find the pieces. 3 is the base. That is the same as the base of our logarithm. So to rewrite this, we would have log base 3. Then we're taking log base 3 of y, which is what our exponential is equal to. Well, our exponential is equal to 81. So we have log base 3 of 81. That is equal to x, the exponent of our exponential, here a 4. So 3 to the 4th power equals 81 is the same thing as log base 3 of 81 equals 4. Here we're saying we take that base of 3 and we multiply it by itself 4 times, and that gives us 81. So now we know more about logarithms. Logarithms and exponentials are inverses of one another. Let's rewrite this problem in logarithmic form. Taking a look at our problem, we have 2 to the 3rd power equals 8. This problem is currently in exponential form. And to take a problem from exponential form and put it into logarithmic form, it would be helpful to recall what a logarithm is. So what's a log? Well, if y is equal to b to the x, then x is equal to log base b of y. In other words, if we have a problem in exponential form, then we can rewrite it in logarithmic form. That's exactly what we're trying to do. So rewriting our problem, we have 2 to the 3rd power equals 8. Now to make our lives even easier, let's identify a couple of pieces in our problem. Let's identify the base. The base in exponential form is the same as the base in logarithmic form. Taking a look at exponential form, the base is the variable b. Looking at logarithmic form, we find that variable b right here. It's the value just to the right and below the word log. Taking a look at our problem, we see this value of 2 is the base. So now that we have the base, let's see if we can identify the exponent. The exponent in exponential form is the same as the exponent in logarithmic form. Looking in exponential form, the exponent is this variable x. In logarithmic form, the variable x is what the log is equal to. And if we look at our problem, we see that 3 is the exponent. So now that we've identified the base and the exponent, let's see if we can rewrite our problem in logarithmic form. Again, we want to rewrite it in this form. So let's focus on writing this right-hand side, log base b of y. Well, we have log. B, remember, is the base, which we found to be 2. And we need to write y. Well, in exponential form, y is what b to the x is equal to. In our problem, 2 to the 3rd power is equal to 8. So, our value for y in this problem is 8. And we set that equal to x. Remember, our exponent which we found to be 3. And now we have log base 2 of 8 is equal to 3. Log base 2 of 8 really means that we just want to find 2 to what power equals 8. Looking back at our original problem, we see that 2 to the 3rd power equals 8. So, log base 2 of 8 is equal to 3. And now we have taken our problem from exponential form and rewritten it in logarithmic form.
In this problem, you will write exponential equations in logarithmic form. What is the logarithmic form of the equation? Part A, 100 equals 10 squared. Use the definition of logarithm. If x equals b to the y power, then log base b of x equals y. To what power do you raise 10 to get 100? 10 raised to the 2nd power equals 100. If 100 equals 10 squared, then log base 10 of 100 equals 2. Part B. What is the logarithmic form of 81 equals 3 to the 4th power? Use the definition of logarithm. If x equals b to the y power, then log base b of x equals y. If 81 equals 3 to the 4th power, then log base 3 of 81 equals 4. In this problem, you will evaluate a logarithm. What is the value of log base 8 of 32? Your choices are A, 3/5, B, 5/3, C, 3, or D, 5. Write a logarithmic equation. How can you use the definition of logarithm to help you find the value of log base 8 of 32? If log base b of x equals y, then x equals b to the y power. So to what power must you raise 8 to get 32? Use the definition of logarithm to write an exponential equation. Write each side using base 2. Use the power properties of exponents to simplify the right side. Since the bases are the same, the exponents must be equal. Solve for x. So, x equals 5/3. Since 8 to the 5/3 power equals 32, then log base 8 of 32 equals 5/3. The correct answer is B.
This problem, you will use a logarithmic scale. In December 2004, An earthquake with magnitude 9 and 3/10 on the Richter scale hit off the northwest coast of Sumatra. The diagram shows the magnitude of an earthquake that hit Sumatra in March 2005. The formula log of I sub 1 divided by I sub 2 equals m sub 1 minus m sub 2 compares the intensity levels of earthquakes, where I is the intensity level determined by a seismograph and m is the magnitude on a Richter scale. How many times more intense was the December earthquake than the March earthquake? In this problem, you will graph a logarithmic function. What is the graph of the function y equals log base 3 of x? Describe the domain and range and identify the y-intercept and the asymptote. In this problem, you will translate the graph of y equals log base b of x. How does the graph of y equals log base 4 of the quantity x minus 3 plus 4 compare to the graph of the parent function?
Thank you for listening. If you have questions, just send your message through Schoology. Have a great day.